To frame our discussion on grand transitions, we must acknowledge a cultural blind spot. As the Google Ngram viewer demonstrates, the frequency of the word agriculture in printed sources peaked in the 1950s and has since faded into obscurity, trailing far behind concepts like population or energy. This data visualizes a civilization-wide indifference. In the pre-industrial era, food production was the central anxiety of daily life. Today, first things first no longer applies to our caloric foundations. While society obsesses over the downstream consequences of nutrition, dieting, obesity, and specific micronutrients, the upstream engine of food production has become a cultural footnote, peaking at a mere 0.004% of mentions. We have effectively intellectually outsourced our survival mechanism, treating it as a solved problem rather than a dynamic, vulnerable system. Mainstream economists frequently offer an argument that is as mathematically accurate as it is ecologically suicidal. Why worry about a sector that contributes only 0.7% to the U.S. GDP? This marginalization is based on a fundamental confusion between economic value and biological necessity. By this logic, the finance, insurance, and real estate sector, which claims over 20% of GDP, is the true engine of civilization. However, this reasoning collapses under the slightest stress test. My counter-proposal to the economists is simple. Let us attempt to metabolize the output of the insurance and leasing sectors. The 0.7% is not a margin. It is the foundation upon which the other 99.3% of the economy rests. The invisibility of agriculture is actually a testament to its staggering success. We pay so little for survival that we value it at nearly zero. The mechanism behind this economic shift is a radical increase in labor productivity. Consider the production of a single kilogram of wheat. In 1800, a New England farmer relying on oxen and flails required over 7 minutes of labor for that single kilogram. By 1900, horse-drawn gang plows and early combines cut this to 25 seconds, an 18-fold increase in productivity. Today, utilizing tractors with 600 horsepower and implements 12 meters wide, that same kilogram requires less than 6 seconds of human attention. This is not merely an improvement. It is a civilization-altering release of labor. It allowed the U.S. agricultural workforce to plummet from 74% in 1800 to just 1.7% in 2000, freeing the human capital required to build industrial cities and, ironically, the very economic sectors that now dismiss agriculture. We must strip away the illusion that modern farming is merely an intensification of biology. As Howard Odum astutely observed in 1971, the idea that we are simply better at harvesting solar energy is a, quote, sad hoax. Pre-industrial agriculture was a solar energy system. Modern agriculture is a fossil fuel conversion system. We no longer eat potatoes made entirely of solar energy. We eat potatoes partly made of oil. Every step of the process, from the diesel in the tractor to the natural gas used to synthesize fertilizers, to the electricity for irrigation and processing, represents a subsidy of anthropogenic energy. We have decoupled food production from the real-time flow of the sun and coupled it to the depletion of geologic carbon reserves. Let us look at the accounting of this transition during the 20th century. While the global population grew 3.7-fold and harvested cropland expanded by only 40%, the anthropogenic energy subsidies injected into the system increased 90-fold. We went from 0.1 exajoules to over 12 exajoules of energy input. By 2015, the total energy for food production reached approximately 20 exajoules per year. While this represents only about 4% of global primary energy use, a surprisingly small fraction, it is an indispensable 4%. Without this energy subsidy, embodied in machinery, irrigation, and chemicals, feeding a population of 7.5 billion would be thermodynamically impossible. We have essentially traded 90 units of fossil energy acceleration to achieve a 40% expansion in land utility. The conversion of fossil energy into food was executed via 3 specific vectors. First and most consequential was the Haber-Bosch synthesis. Without the ability to synthesize ammonia from atmospheric nitrogen and natural gas, growing from 4 Mount in 1950 to 150 Mount recently, we could not sustain approximately 45% of today's population. Second was mechanization, where the internal combustion engine replaced the horse, releasing the quarter of U.S. farmland previously dedicated to growing feed for draft animals. Third was the genetic revolution, specifically the quote-unquote green revolution short-stalked wheat varieties. By increasing the harvest index from 0.2 to 0.5, We re-engineered the plant to allocate more energy to the grain rather than the straw, doubling output per plant. These three revolutions form the tripod of modern abundance. The surplus of grain enabled a fundamental structural shift in animal husbandry, the rise of the landless farm. In 1900, a typical farm was a mixed operation with cattle, pigs, and chickens living in a symbiotic cycle. Post-World War II, we decoupled animals from the land, moving them into concentrated animal feeding operations, CAFOs. These are protein factories entirely dependent on trucked-in compound feeds. Global compound feed production has exploded to over 1 billion metric tons. Consequently, our cropping system shifted. In the U.S., 2/3 of domestic crop consumption is now destined not for human plates, but for animal troughs. We effectively transformed American agriculture into a machine for converting fossil fuel fertilized corn and soy into animal protein. We demanded efficiency from our animals, but results varied by species. This chart tracks the feed conversion ratio, units of feed required per unit of live weight. Beef production, the top line, has remained largely stagnant. The metabolic cost of a large ruminant is high and immutable, requiring at least 25 units of feed for 1 unit of edible meat. The true revolution occurred in broilers. Through intense selective breeding and optimized nutrition, we reduced the time to market from 3 to 4 months to just 6 weeks, and the feed ratio dropped from 5 to 1 to 1.71. We have essentially turned the chicken into a hyper-efficient machine for converting grain into protein, making it the dominant meat of the modern era, while beef remains a luxury of metabolic inefficiency. To understand the magnitude of this shift, we must remember the baseline of human history: monotonous subsistence. In the late 1700s, oat bread and water pottage were standard. In early 1900s Japan, a mix of barley and rice was a luxury. Traditional diets derived over 66% of energy from staple grains. The modern diet has inverted this. As wealth and productivity rose, we saw a massive substitution. Staple grains retreated to less than 33% of energy intake, replaced by lipids, sugars, and animal proteins. In Spain, meat supplies skyrocketed from effectively 0 to 112 kilograms per capita. We moved from a world where breaking bread was literal survival to a world where sugar supply in the U.S. has doubled to 69 kilograms per capita. We engineered a feast that never ends. Here lies the great failure of the industrial food model. We produce so much that the surplus has become a pollutant. In the United States, the gap between food supply, approximately 3,700 kilocalories, and physiological necessity is so vast that the wasted energy, approximately 1,400 kcal per person per day, could provide adequate nutrition for the entire 200 million person population of Brazil. This is not merely leftovers. It is a massive squandering of the land, water, and fossil energy used to produce it. Behind every unit of wasted meat are 3 to 5 units of wasted plant crops. We have optimized the production line but broken the consumption loop, creating a system where 40% of output acts as nothing more than landfill filler. The age of abundance has fueled an epidemic of obesity. For decades, U.S. obesity rates were stable at under 15%. The inflection point in the late 1970s correlates with the explosion of cheap caloric availability and the dominance of processed foods. Today, 3 in 4 American adults have an abnormal body mass index. This is not a failure of willpower. It is a successful adaptation to an environment flooded with energy-dense, highly palatable, and inexpensive food. The trend is global and accelerating. The number of obese children worldwide increased tenfold in just 4 decades. We are witnessing a historical anomaly, where the primary threat to public health is not the absence of food, but its aggressive overpresence. As our diets transformed, our attempt to understand the health implications led to decades of what we now know was flawed dogma. For 40 years, the low-fat ideology reigned supreme, demonizing butter and eggs based on the assumption that dietary cholesterol drove heart disease. We replaced saturated fats with refined carbohydrates and polyunsaturated vegetable oils, yet the population grew fatter and sicker. Modern rigorous meta-studies have upended this, finding no clear association between saturated fat intake and all-cause mortality or cardiovascular disease. We are learning that nutrition is not about isolated nutrients, but about complex metabolic interactions, and that the low-fat experiment was a public health failure that likely exacerbated the very problems it sought to solve. The success of modern agriculture has fundamentally reshaped the planet's surface. We now devote 40% of the world's ice-free land to croplands and pastures. Since 1700, pasture land has increased sevenfold, largely at the expense of tropical forests. This transition is responsible for 20 to 30% of all global greenhouse gas emissions, more than the entire transportation sector. We see this physical scarring in the vast monocultures of the Americas and the plastic-covered landscapes of Almeria. The agricultural transition delivered us from famine, but it has left us with a severe environmental debt: soil erosion, coastal dead zones from nitrate leaching, and a massive carbon footprint. The challenge of the next century is not just production, it is reconciliation with these planetary boundaries.